Okay, so we're going to take a look at section 6.3, at least part of it. We're not going to do the inequalities piece of it on our assignment, just the equations. So we're going to look at square root functions, and our learning target is that we'll be able to graph square root functions. But before we get into that too much, I want us to think back to a type of question that we would have done yesterday, or the block day, I should say. If we think about this function, f of x equals x squared, I want us to find the inverse function. So, refresher in case you've forgotten, we swap out the f of x and the x, so the f of x turns into an x, and the x will turn into an f of x. I'm going to call it inverse of f of x. And so I'll just take that notation and put it in parentheses and square it. That's probably the best way to address the fact that it's squared. And then we need to now solve for the f of x. So I have to get rid of the square. So the way we would get rid of a square is by square rooting. And hopefully I've talked about it enough recently that you know that if you square root to solve an equation, you have to remember the plus minus. Just do it to the other side and you do a plus minus. So since it was the right side I cared about, and I'm trying to isolate, I put the plus minus there on the left side. I'll swap sides now while I'm at it as well, but I just have the inverse of f of x equals plus minus the square root of x. So what we also did, I looked at a little bit in that last section, was we took a look at the functions, the graphs of them rather, and how they compared. So let me do that real quick. Let me actually give us a little graph background. Okay, so let's sketch that f of x. I don't want to spend a lot of time on refreshing how we graph a quadratic. We already did that chapter. But this one would have a vertex at 0, 0. It would go through 1, 1. So negative 1, 1 as well. And then it would go through 2, 4. Negative 2, 4. That's probably good enough to sketch our graph. Oops. Okay, so that's not new material. That's just graphing a parabola, which was chapter 4. That was our f of x. I just didn't make my table of values. But what we talked about yesterday or what we talked about in the last section is if I draw the line y equals x, or just f of x equals x, to get the graph of the inverse, what do? I reflect it over that line. So 0, 0, if you do the inverse of 0, 0, it's still just 0, 0. 1, 1, if you invert 1 and 1, you still get 1 and 1. Negative 1, 1 becomes 1, negative 1. 2, 4 becomes 4, 2. Negative 2, 4 becomes 4, negative 2. And we get our sideways parabola. Right? We talked about that in class in the last section, but that's what its inverse looked like. What I want to highlight now, because today's section we're going to be graphing square root functions. Remember what the inverse function was. Wasn't it a square root? There's actually two of them, because doesn't that mean positive square root of x and negative square root of x? When I put both of those graphs together, apparently it gives me this sideways parabola. we talked in that same lesson that sideways parabola is not a function because it doesn't pass the vertical line test. But what we see here is that's actually a positive square root function and a negative square root function. So when I look at just one of the square root functions, it's really just half of that graph. If I actually erase up to that starting point right there, that graph in blue there, that is the square root function. That's what the graph looks like, the positive one. And so then the negative one would have been the bottom part, the part that I erased. And when we put them together, we end up with that full sideways parabola. But a square root is really just half of a sideways parabola. There we go. Okay, so you see it there again. We are going to today we're not really looking at inverses anymore, but you can see that there's a connection to what we did last time. We're going to just look at the square root or the graph of a square root. So not the two of them combined. So we're not going to end up with the full parabola. We're going to sideways parabola. We're going to have just one of them, one or the other. And notice, remember, when we take that bottom one away, we now pass the vertical line test. It is now a function. A square root is a function. When I threw both of them up there, it didn't look like a function, but when we understand that this is actually two different functions put together, then it works. Okay, so that's kind of a little, yeah, I'll leave this graph paper up there. That's kind of a little introduction or a tie into what we did yesterday. We're going to actually start graphing square roots now. And I want to start with the parent function, which is really the one I have graphed up there. But consider f of x equals square root of x. So that's just the most basic square root function. Sometimes when I graph, it's nice to make a table of values. And when we've made a table of values in the past, we just kind of picked what x values we wanted, and maybe we picked x values that worked nicely. This is the very first time in Algebra 2 that we have encountered a problem where I can't pick just any x value. There's actually restrictions or limitations on what I can pick for x values. What can I not use? Negative. Now, we do know how to deal with square roots of negative numbers. They're imaginary, but we don't get to graph them. They don't show up on our graph. So because of that, we don't want them. Since we're graphing square roots, we don't want negatives. So when I pick my x values, I can't use a negative. If you do, it just becomes imaginary, doesn't show up on your graph. So then it didn't do you any good. So I want to pick numbers that I can graph, that do show up. And it's very important to correctly show the graph. We need to get the very first possible value. Since there's things you can't plug, we need to make sure that we get the very beginning. What is the smallest x value that I could plug in? 0 is correct. Can I do square root of 0? What is the square root of 0? If I plug 0 in, square root of 0 is 0. Yeah, so we get this order pair. I guess technically I shouldn't be saying y, I should be saying f of x here. I'm not that concerned about if you use y instead. But the f of x became 0. Anything less that I used in the x value wouldn't have worked. Let's think about some other values that I can use. I want to be strategic, so I want to get ones that work out nicely when I plug them in. So the next one after 0 that works nicely is 1. What is the square root of 1? Good, so when I plug 1 in, I get 1. What's the next one? 4. 4 is a perfect square. So when I square root 4, I get 2. The next one would be 9, which would give me 3. The next one would be 16, which will give me 4. And then it'd be 25, 36. I don't want to graph all of those. I'm not going to make my graph that big. Really, probably, I think 3 points might be enough. But let's go ahead and graph this. Oops. So 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Right, and I could keep going, but you should be able to see the pattern here. And we knew from above that it was really just half of a sideways parabola. There is no bottom part to this one. Why did we have a bottom part to the one above it? Because we had a positive and a negative. If I did negative square root of x, it would have just been the reflection of that, would have been the bottom half. So the positive one is only that top half. Now, I'm not really going to make my graphs that big in the future, but I understand that as it travels to the right, it gets steeper and steeper. I want to point out to you the left side of this graph. Anybody observe what I used for the left side of my graph? Or maybe better yet, what I did not use. Look at the right side of my graph. Look at the left side of my graph. What's true about the left side of the graph? It's a starting point or an ending point, depending on which way you look at it. It's not, it doesn't have an arrow, it doesn't go through it. Would you be wrong to do something like that and extend it too far? Would you be wrong to do something like that? Yeah, both of those would be wrong because they show an incomplete understanding of a square root. A square root does have a beginning point. I need to see that beginning point, and then we travel to the right. It's a little bit like in geometry, you did rays and you did lines, or rays and line segments, things of that nature. And with a line in geometry, you put an arrow on both sides, right? But with a ray, it was like that. A square root is like a ray. It's not linear, but it has an endpoint on the one side. So be careful, please. That's what I expect to see when you graph a square root function. I want to see that endpoint on the left side. Anything to the left of that would have been undefined. Now, let's talk a little bit about domain and range. Every problem that we've done in Algebra 2 prior to this one had a domain of all real numbers. Are we allowed to use all x values in this problem? No, this is our very first problem that didn't have an all real number domain. What is the domain here? What x values could I use? X had to be greater than or equal to 0. What about the range? Well, if I had the other half of the ups or the sideways parabola, it would have been all real numbers, but I don't have the other half. My range is going up to positive infinity, but it has a lowest value to it. So we know that f of x was greater than or equal to also a 0. So this is the parent function. The parent function of a square root. Because there were no numbers, and there really. And so we can make transformations of that. So the general form is this. I could use a multiplier in front of my square root. I would call that multiplier x. I could have a number added or subtracted to x. So inside my square root, I'm going to say x minus h. And then at the end, I could add a number or subtract a number. I'll call that k. So there's our generic form. Have we seen those letters before? We have. We've seen them every chapter, actually. And we will see them, I think, about almost every chapter after this as well. You should get used to seeing A, H's, and K's. Does anybody recall what kind of transformation we get with an H value? H value is your horizontal shift. It will go left or right. What is your K value? Vertical shift, it will shift it up and down. What does the A value do? Stretches or compresses vertically. And the other thing that can happen here is that the A value could be negative. If the A value is negative, what do you get? Reflected. Just like up here. Remember, we have up here, I have two of them. I have the top one, and then I have the bottom one. The bottom one was the negative one, so it reflected. So your A value can flip it. You can write those notes down that that's what A does, that's what H does, that's what K does. We have written those down every chapter. So hopefully you're starting to remember that. So understanding that, let's try to graph some square roots that are maybe a little bit more complex than the parent function. Okay, we're going to graph this. F of x equals 3 square root of x minus 1 plus 2. It may be helpful to make a table of values. You also know it's a square root, and before, what x values were nice for our square root? 0, 1, and 4. Let's think about those. So I don't want to make my graph too big. 0, 1, and 4. Will they work nicely in this problem? 1 will. 0 will not. 4 will not. If you plug 0 into your square root, you would say 0 minus 1, which is a negative 1. Can you have a square root of negative 1? Well, you'd have imaginary, but we can't graph that, so that doesn't work out nicely. So we want to be strategic about the numbers that we choose. Now, if we think about what we just said about horizontal, especially horizontal at the moment, transformations, we can use that strategically to know what x values to use. So think of it this way. Our graph is shifting what direction? 1 unit, what direction? It goes the opposite direction. So this is going to shift it left 1. When you shift left 1, sorry, I repeated somebody else. I heard left 1. Is it actually left 1? We were wrong. Yeah, so I think someone else said right, and I should have repeated them instead. I wasn't thinking. We go the opposite direction. So it looked like it was going to be negative, but it's actually right. Right 1. While we're at it, the 2 is going to do what? We're going to go up 2, and the 3 is going to stretch it. I don't have to worry too much about that stretch. It's mostly the right 1 that I want to focus on at the moment. If we're shifting right 1, how do I use the 0, 1, and 4 that I had before and move them all right 1? I would just add 1 to each of them. Think about the 0, the 1, and the 4 that we had before. Add 1 to each of them. 1, 2, 5 are going to work out nicely. Plug them in to verify. When you plug in 1 into the square root of 1 minus 1. Oh, that's 0, and I can do the square root of 0. The square root of 0 is 0 times 3, still 0, and then add 2. Hey, take a look at that point right there. That's what I would call my starting point. Could I have anticipated that from the equation? Yeah. Maybe back up here where I put that general notes, I could go ahead and add that the starting point is always going to be, we have the opposite sign of that, so positive h. Okay. So here I have a positive 1, 2 is going to be my starting point. That's not just coincidence, that'll always be the case. Okay, now let's plug in 2 because we anticipated that 2 is going to work out nicely. 2 minus 1 gives us 1. And the square root of 1 is 1 times 3. It's 3 plus 2, 5. Notice how much did it grow by, the y value? 3. What's your a value? 3, huh? I wonder if that's a coincidence. Let's plug in 5. 5 minus 1. 4. The square root of 4. 2. 3 times 2. 6. 6 plus 2. 8. How much did we grow by? Oh, 3 again. That's coincidence. No, maybe not coincidence. I think 3 points is enough. I think that's enough information to draw a graph. If you want to do more, you can. One, 2, 2, 5, 5, 8. Connect your dots. Remember, it's part of a sideways parabola. But that left point, the left point is an endpoint. Do not make your line go through it. And do not put an arrow there. That is an endpoint, it's where it begins or ends, whichever way you look at it. You will be asked about domain and range on these problems. And especially now that they're not all real numbers, I'm really interested in making sure you understand domain and range. What is the domain in this problem? The smallest x value I could use was 1, and everything beyond that worked. Now, I only chose the 1, the 2, the 5, but that's just because those worked conveniently. They're relatively small. But everything greater than 1 would have worked. What about the range? Not x, but f of x is greater than or equal to 2. Let's do one more. On the Thursday before break. Yeah, next one, Tuesday. My dad's sports schedule is not on me. I'm like, you have to tell you, I'm not going to. I'm not getting kicked out of show. All right. We should be a little faster at this time. What's my starting point going to be? -3, -4. We look at those numbers. You do the opposite of the one in the square root. So that's why I have -3 and then -4. That becomes my starting point. But to figure out what other numbers, maybe I could have thought of 0, 1, and 4 because those are nice numbers to square root. But what are we doing to each of them this time? We're subtracting 3. We have h value of -3. So if you subtract 3 from each of those, you will end up with 3 numbers that work nicely. So 1 minus -3, or sorry, 1 minus 3 rather, is -2, and 4 minus 3 is 1. -3, -2, and 1 should all work nicely when I plug them in. So once again, 0, 1, and 4 I use because it's a square root. Then I look here, my h is the opposite sign of that, so a -3. That's what I did. That's how I adjusted the 0, 1, and 4. I subtracted 3 from each of those. So then to get your y values, plug them in. Plug in -2. -2 plus 3 is 1. Square root of 1 is 1. Times -1/2. It's kind of, we're going to have a fraction here, -1/2. Minus 4, well, that'd be -4.5. Plug in 1. 1 plus 3 is 4. Square root of 4 is 2. -1/2 times 2 is -1. -1 minus 4 -5. Notice what happened on my y values. Went from -4 to -4.5. I went down a half, and then I went down another half. What's my a value? Oh, coincidence or not. -3, -4. -2, -4.5. 1, -5. Notice it got compressed vertically. It's not growing as fast. It's not nearly as steep. It also got shifted left 3 and down 4. And which way is it opening? Is it opening up or down? Oh, this one's opening down because the a value was negative. Domain? X was greater than or equal to -3. Your range, this is a g of x this time. G of x is, notice this one's opening down, so we'd have to say less than or equal to -4. Notice the h and the k show up in your domain and range. All right, if you look in the textbook, you'll see there are some inequalities in there in this section, but your assignment is just over the equations, so I'm going to stop there.